Hi friends, my name is Baji. Welcome to our channel. In today's video, we will discuss conditional structures, which allow us to control the flow of program based on certain conditions. We will go through different types of conditional structures with some examples. If you are watching this performance testing must-have skill series for the first time, please watch the previous videos first and then continue this video. You can find the series playlist link in the description. So without any further delay, let's get started. Let's open the Visual Studio Code to make some notes as well as to test the examples. I have already created a separate file with the name groovy-part5.groovy for making all the notes of this video as well as the example. If you want to follow along, you can also create similar file or you can use the existing file. Just make sure that the file name ends with .groovy because Groovy compiler will only understand the files that ends with .groovy. Okay, so in every programming language, the code that we have written will be executed sequentially. For example, if that program contains 100 lines of code, then the programming language will execute that 100 lines of code sequentially one after another, irrespective the type of language that you are using. Okay, but to meet some specific scenarios, we don't want all 100 lines of code should get executed sequentially. We want some portion of code should only get executed when some condition met, right? So to meet that kind of requirements, all the programming languages introduced a concept called control structures. Basically, these control structures are used to manage the flow of execution in a program. They dictate the order in which the statements are executed based on certain conditions or loops. So instead of statements executing sequentially, they run in an order specified by the control statement. So Groovy provides several control structures similar to Java because Groovy is superset of Java. So whatever the control structures that are available in Java can be used in Groovy as well. Okay. So the main control structures that Groovy provides are conditional structures, loop structures, and exceptional handling structures. So these are the main control structures that Groovy provides to support the different scenarios. In this video, we will discuss different types of conditional structures that are available in Groovy, and in the upcoming video, we will talk about loop structures and exceptional handling structures. Okay, so these conditional structures allow us to control the flow of program based on certain conditions. So we have different types of conditional structures available, and they are if else, switch case. We will go each conditional structures in detail with some examples. Okay, first let's look at the if else conditional structures. Basically, this type of conditional structures allow us to conditionally execute different blocks of code based on whether a given expression or condition evaluates to true or false. That means Groovy will execute some block of code based on the condition evaluation. If the condition is getting evaluated as true, then certain block of code will be executed. If not, then the other part of the code will be executed. Okay. Now let's look at the syntax of if else. So Groovy is a case sensitive, so make sure that you are giving the keywords in lowercase as specified in the syntax. Okay. First we will start with the keyword if, and then there is a space. After that, within parentheses, we should be giving the condition. So which condition we want Groovy to evaluate. Okay. And then a opening curly braces. After that, we should give the code to execute if the condition is getting evaluated as true. So that means if Groovy evaluate that condition as true, then Groovy should execute whatever the code that we have written after this opening curly braces. And after that code, we should be giving the closing curly braces. That means the piece of code between the opening and closing curly braces will be executed if the condition is evaluated to true. If that condition is not evaluated true, then we need some portion of code to be executed, right? So that should be given as an else block. So here else is a keyword. Again, there is a space and opening curly braces, and then whatever the code that we want to execute if the condition is evaluated to false, and then closing curly braces. Else is optional here. If you don't want to execute anything if the condition is false, then you can simply remove that else. But if you want something to be executed if the condition is getting evaluated as false, then you should be including else block as well. Okay, so this is the basic syntax of if else. So let's quickly look at one program to understand this syntax. Let's say we wanted to test if a given number is a positive number or a negative number. So let's use the if else conditional structure and then write the code. Okay, first we will declare a variable diff num equal to 10. So we want to store some value in a variable called num. Now we will evaluate this num, and then based on that we will tell if the given number is positive or negative. So how do we know if a number is a positive or negative? In basic math also, if the number greater than 0, then we consider that as a positive number, and if the number is less than 0, then that is a negative number. Okay, so we will use this condition to evaluate if that given number is positive or negative. So let's let's write the if statement. If space within the parenthesis condition. So what condition we wanted to write? Let's check if num greater than 0. In the previous video, I have explained you the relational operators, right? So greater than relational operator will be used to evaluate two operands if one operand is greater than the another one. So that is what we are trying here. We are telling to Groovy that if number greater than 0, then execute this block of code. So if you are having opening curly braces, make sure it has a correspondent closing curly braces as well. Otherwise, Groovy will not understand where to end. Okay. So here we just print a simple message, println. So we are telling the given number is positive. So if the number is not positive, we wanted to print a message called the given number is negative. Okay. So then include the else block, println the given number is negative. Here I am using the string interpolation concepts to evaluate the value inside that variable. So let's run the program. To run the program, we will go to terminal and then type Groovy and file name. What is our file name? Groovy space part5.groovy. We got the output. The given 10 is positive. Where did we store the 10? In num. So that is what here, right? So that means Groovy evaluated this condition. So num, what is the value inside num? 10. So 10 is 10 greater than 0? True. So that is why it executed this piece of code. Let's make it as -10 and then try to rerun the same program. See, now it is telling that the given -10 is negative. So here again it came here and then it evaluated this condition. So this time what is the value inside num? It is -10. So is -10 greater than 0? No, it is not. This condition evaluated to false. So it will skip this block of code and then it will come to else and it will execute the piece of code that we have written inside the else block. Okay. Sometimes we want multiple conditions to be evaluated in this type of conditional structure. For example, let's make this number as 0 and then try to rerun the program. This time it is telling that the given 0 is negative, but in reality that is not true, right? But the Groovy is executing, but Groovy is doing his job correctly, because here we said if number greater than 0, whatever the value inside the number is greater than 0, then it will execute this block of code. Otherwise it will execute this block of code. So this time the number equal to 0. Is 0 greater than 0? No, it is equal to 0. Since this is not true, then Groovy will come to else block and will execute this piece of code. That is why we got this message. So in this type of situations, we want multiple conditions part of if block so that we can evaluate multiple conditions and execute specific block of code. Okay. So how do we do that? Let's understand the syntax first and then we will go through the example. The syntax for evaluating multiple conditions in the if block is pretty much same as the previous one. Only thing is we will be adding additional block with some conditions. So Groovy can evaluate and then execute the piece of code if that condition evaluates to true. Okay. So first we will write if keyword and within the brackets we will write the condition and then opening curly braces and closing curly braces. Within that we will write the code which we want Groovy to execute if that condition is evaluated to true. If that condition is not evaluated to true, instead of going to else, we want Groovy to check another condition. So we are writing else space if. So you are telling Groovy, okay, if my first condition is not evaluated true, don't directly go to else, check this second condition. So that is why we are saying else space if space again the condition and opening curly braces and closing curly braces. Within that we will put all the code if the second condition evaluates to true. If that second condition is also not evaluated true, then Groovy will execute the piece of code that is given in the else block. Okay. So we will take the same example what we just executed and then add the else if condition. So instead of writing direct else, maybe we will put the condition here in else if number less than 0. So that means we want Groovy to check the second condition. If the number is less than 0, then only we want Groovy to print that the given number is negative. Okay. Otherwise else we can say the given number is 0, right? Because the number can be either positive or negative or 0. Only these three conditions, right? So when we execute the program, first Groovy will evaluate this condition. It will check whatever the value in number, and then if this condition evaluates to true, then it will execute this print statement. If not, then it will come to else if block and again it will check the condition. If the number less than 0, then if this evaluates true, then it will execute this piece of code. If both conditions evaluates to false, then it will jump to else block and execute the else block of code. Okay. So let's rerun the same program. See, now we are getting the right output, right? So since the number is 0, then these two conditions evaluates to false and Groovy executed the else block. Let's make this number again as 10 and then try to rerun the program. It is always recommended or a best practice to test the program with multiple inputs. We don't want to assume anything that our program is working as expected, right? Try to give multiple inputs and then see how your program is working. Now I have number 10. So Groovy comes to the if condition first it says if 10 greater than 0, in this case yes, so it will simply execute this code and then ends the code, because the other piece of code will only get evaluated if this condition evaluates to false. Otherwise Groovy will simply execute the block of code belongs to true and then skip the rest. Okay, so let's make this as -10 and then rerun the same program. So this time we are getting the given number -10 is negative, which is correct because the number is not greater than 0, -10 is less than 0, so it did not execute this statement because the condition evaluates to false, and then it checked the next condition. Here this time this condition is true, then it executed the line number 14 code. Okay, I hope you understand the if else and if else conditional structure. Please let me know if anything is not clear. Okay, in our previous video I have mentioned that I will explain the conditional operators after explaining the conditional structures, right? So let's look at those conditional operators now. Basically we have two types of conditional operators: ternary operator, Elvis operator. So the ternary operator is a concise way to express the conditional logic and is often used for short or one-line expressions. It can make code more readable when conditions are straightforward. Okay, so let's look at the syntax now. The syntax is first we have to mention the condition and then space, after that question mark, and then there is a space, and if that condition evaluates to true, whatever the code that we want to execute, we should be specify here, and then semicolon, and then if the condition evaluates to false, the code goes here. So let's try to write a program. So we want to check a number. If that number is greater than 5, then we want to print greater than 5, otherwise we want to print less than 5. So first we'll try to develop the program using the if else condition, and then we will convert that if else to this ternary operator, so that you will understand how much easy to write the same piece of code. So let's declare a variable called x, and then we will also declare a variable to store the result. Now we will write the condition. So we want that number to be evaluated with 5, right? So if number greater than 5, then we want to store some value like greater than 5. Otherwise else result equal to less than or equal to 5. Okay, so if the number is not greater than 5, then either it will be a less than number or equal to. Okay, so that is why we have used that statement. So after that we'll print the result. So we know what is the outcome, println result. You can use directly the println statements here instead of storing this into a variable and then printing thereafter, right? I just wanted to show different ways to write the program. That is why I have used the variable in this example. Okay, so let's try to run the program. So Groovy is telling that the number is greater than 5, right? So what we stored in x? 10. So is 10 greater than 5? Yes. So that is why Groovy executed this piece of code, because this condition evaluates to true, then it executed this code and stored this value into result, and after that it skipped the rest of the code and then came to the println statement and executed the println and display the output. So in result we stored greater than 5, that is why it displayed the greater than 5. Now let's try to rewrite the same program using ternary conditional operator. So let's use the same two variables, x and result. The syntax is first condition. So what is the condition? X greater than 5, right? And then what we said, question mark. If this condition evaluates to true, we wanted to store greater than 5. So greater than 5, if not less than or equal to, where we want to store in a variable called result. So result equal to this. So when Groovy comes to this line, first it will evaluate this condition. If this condition evaluates to true, then it will take this piece of code and store it in the result. Otherwise it will go to this piece of code and it will take this particular statement and store it in the result. Let's try to print the result, see whether we are getting the same output or not. Okay, let's run. So we got the same result. So instead of writing this much if else block, you can use one line of statement to achieve the same output. Let's give the number as 3, okay, and rerun the program. So now we are getting less than or equal to 5. That means our program is working as expected. So you can use the ternary operator to express the conditional logic in a more concise way. Okay, now let's look at the next type of conditional operators, which is Elvis operator. Basically it is a shorthand notation for expressing conditional check and providing a default value when the check evaluates to null. That means if the conditional check evaluates to null, instead of passing null value, we wanted to pass some default value. In those type of scenarios, you can use Elvis operator. So the syntax for Elvis operator is, we are again in this example we are storing the outcome into a variable. That is why we are saying variable equal to, and here we are saying the expression, and after that question mark, colon, and then default value. Let's try to write some code to understand this Elvis operator. So I'm declaring a variable called sample text. I'm declaring another variable called Elvis output equal to sample text question mark colon default message hello Groovy, and then we will print the Elvis out. So here what we are doing is, in line number 83 we defined a variable called sample text, and in line number 84 we have used the Elvis operator, and we specified the sample text variable, and then after that question mark colon, and we provided some default message. So when Groovy comes to the line number 84, it will check the expression sample text. If the sample text has any value in it, so it will directly store that value in the Elvis output, otherwise it will store the default. So in Groovy we have a concept called Groovy Truth, which I will be explaining after switch case conditional structure. So if the string is not empty, then Groovy will evaluate that expression as true. This particular string is not null, then use the same value whatever there inside the sample text, otherwise use the default message. Okay, so let's try to store some string, let's say sample value. Okay, and then try to rerun, see what will happen. Looks like there is a typo, so instead of sample text I said sample text, that's why it failed. Let's try to rerun the again. So now it is getting the default message hello Groovy, because sample text does not contain anything. So let's try to store some value inside the sample text and then see what will happen. So sample value, and then try to rerun the program. Instead of default message hello Groovy, it is taking the value inside sample text and storing it in the Elvis output. So if you have this kind of scenario, then you can use the Elvis operator. If you expect some null values in variables and you don't want to store those null values, instead you want to store some default message, in such scenarios you can use this Elvis operator. Okay, now let's look at the second type of conditional structure, which is switch case. Basically it allows you to evaluate the value of an expression against multiple possible values and execute different code blocks based on the match. It is pretty much similar to if else. This is another way of using conditional structures. So here the Groovy will evaluate the condition with multiple possible values. If any possible value matches, then it will execute the match block of code. Okay, so let's try to understand the syntax first, and then we will look at some sample program. So the syntax is, first we will declare some variable, because this is a variable we are going to use to evaluate possible matches, and then we will use the keyword called switch, since it is a switch case conditional structure, and then within the parenthesis we will specify the variable. After that, same like if, we will have the opening curly braces, and then we will have a keyword called case space value 1. So if that variable matches to this value, then we want some portion of the code to be executed, and that code should be mentioned underneath this case block. Once that code is done, then we should be given the break statement. So that way the code will end here, otherwise it will continue to execute the next conditions. So this is very important. We should always mention break at the end of that block. Here we don't need to specify opening and closing curly braces, same like if block. So that is why the break statement is very important. After that, we should be specifying the second value, so case space value 2. So Groovy will check the variable against this value. If that matches, then it will execute this piece of code, and then again we should keep break. So we can keep n number of cases like this with the possible values. So Groovy will evaluate the required case and execute the specific block of code, and then finally we will have a default. In case any case is not matched with the value, then Groovy will execute the code mentioned under the default block. If none of the cases matches, then Groovy will execute the default code. So let's look at one sample program. Here we are defining a variable called day, and then we are storing Monday. Okay, and then we are using that day as a variable in the switch case to evaluate multiple cases. So switch space day, and then opening and closing curly braces, and then we are saying case space Monday. This is one of the possible value in that variable. So when Groovy comes to this place, so it will check if the day is equal to Monday. If it is Monday, then it will execute this line of code, and after that we want to end the switch case execution, so we are putting the break. When Groovy sees break, then it will not execute rest of the code. For example, if the day is not Monday, then it will come to the next case. It will check again, okay, is the day Friday? If yes, then it will execute this piece of code, and then it will break. If the day is not Monday, or if the day is either not Monday or Friday, then it will execute the default statement. Then it will execute the default block of code. So let's try to run the program. It says it's the start of the week. Since the day is Monday, the day stores Monday, it executed this line of code. Let's make it to Friday and then rerun the same program. Weekend is almost here because we mentioned this println statement. Weekend is almost here. That is why it printed the weekend is almost here. Okay. Let's say we make it to Tuesday. In this case, the day is not matched with these two cases. The expectation is it will execute the default block of code. Let's run the program. So it is telling that it's a regular day. So this is the way we can use the switch conditional structure. So within the switch, it is not only, use some variables here. We can also use some some conditions. You can also use condition if that condition evaluates to true, or I hope you understand the switch case conditional structure. Let me know in case anything is not clear. Okay, now let's discuss the final topic, which is Groovy Truth. Basically, Groovy decides whether an expression or condition is true or false by applying some rules. With Groovy Truth feature, we can write less code in conditional expressions to evaluate the condition is true or false. Okay, so with Groovy Truth feature, we can write less code in conditional expressions. That is the main benefit. So we will see what are all the different rules that Groovy applies when it tries to evaluate the expression. Okay, so first one from the list is Boolean expression. So in condition, if you are specifying the word true, then Boolean evaluates that as true because that is a Boolean value, right? So if Boolean sees as true, then Boolean will assume that condition is true and then it will execute the relevant block of code. If we are specifying false, then Boolean will evaluate that as a false condition. Okay, and the next rule is collections, arrays and maps. If Groovy sees any non-empty collections, arrays and maps, then it will evaluate as true. We will talk more about these collections, arrays and maps in the upcoming videos. For now, just assume that any non-empty collections, arrays and maps will be evaluated as true. And the third rule is strings. Any non-empty strings are evaluated true. If you are only giving string in the expression and you are expecting some Boolean evaluation, then Groovy will verify that string, and if it is non-empty, then it will return true, otherwise false. The next one is number. So any non-zero numbers are considered as true. So again, if you are giving a number in the conditional expression, then Boolean will evaluate that condition as true. The final one is object references. So any non-null object references are considered as true. We can make use of these rules and write less code in the conditional expressions. Now let's look at some example to understand this Groovy Truth concept. Here I have defined a variable called truthy string, and inside that variable I stored hello Groovy, and after that I have a if condition which is checking if this variable is not null. So if this is not null, then I want the string is not empty to be printed on the screen. So that is the expected outcome from this program. Okay, let's try to run this program and then see it is working as expected. So Groovy part5.groovy. So when Groovy comes to line 118, it will check the string. So does it have any value inside? In this case, yes. So since this condition evaluates to true, it executed this. So using the Groovy Truth concept, we can simplify this statement. We don't need to write not equal to null, right? I mean, we can specify simply the string name. We can simply write the string variable here. Let's try to rerun the program and see what will happen. We got the exact output because when we are specifying string variables inside the condition, Groovy will apply the truthy rules and evaluate the condition accordingly. So here we are specifying string variable. So Groovy will check if the string is empty or not empty. If the string is not empty, then this will be evaluated as true, otherwise false. Since the string is not empty, it evaluated true and then it printed this statement. So let's include else block and say the string is empty. Okay, and then try to remove this assignment and rerun the same program. Now we are getting the string is empty. So this is the main benefit of Groovy Truth. So we don't need to write full conditional expressions here. We make use of Groovy Truth syntaxes. So Groovy will apply the Groovy Truth rules and then evaluate the expression whether it is true or false. So I will give you some if-else questions as well as switch case questions for practice. So you can find those questions in the notes. So please try to do some practice using the if-else conditional structure and switch case conditional structure so that you will understand this concept very clearly. So if you have any questions while practicing those programs, please feel free to mention it in the comment section. Okay, so that's it for this video. Thank you so much for staying till the end. I hope you understand the conditional structure that I explained in this video. If any part is not clear or if you need more detailed explanation, please feel free to mention it in the comment section. All these notes have been already uploaded into GitHub and you can find the link to that GitHub file in the description. Okay, so if you are new to our channel, if you enjoyed this video and found the information helpful, please don't forget to hit that subscribe button. By subscribing, you will stay updated on all our future content. If you liked what you saw today, please give this video a thumbs up. Your support means a lot and helps me continue creating content for the community. If any of your friends are interested in learning performance testing concepts, please share this series links to them so that they will learn all these concepts for free and get benefited. So I'll see you with our next video in this module. Until then, take care, stay safe and keep learning.